On the afternoon of November 10, 1943, at the primary aircraft testing facility operated by the German Luftwaffe, a figure of significant importance strode deliberately across the expansive tarmac. His name was Hans-Werner Lerche, the chief test pilot for Germany's esteemed aerial armada. The object of his focused attention was a captured aircraft, a Republic P-47 Thunderbolt, that had been seized 2 weeks earlier under circumstances that were still fresh in everyone's memory. This particular aircraft was stationed prominently on the open field, seemingly awaiting inspection or perhaps a decisive evaluation. To any seasoned observer, it was apparent that the aircraft's appearance was more than just peculiar. It was almost grotesque. Its form suggested a strange, bloated silhouette, reminiscent of a sturdy yet ungainly creature, one that had been humorously nicknamed by German pilots as the Flying Milk Bottle due to its stout, rounded fuselage and exaggerated proportions. Lerche moved slowly toward the aircraft, his mind circling around the reports and intelligence briefings he had meticulously studied beforehand. According to these reports, American fighters of this type were regarded by many in Germany as crude, mass-produced machines assembled by a nation that, at the time, was better known for manufacturing household appliances, things like refrigerators and washing machines, than for crafting high-performance fighters. The P-47 Thunderbolt, in particular, was considered the epitome of American engineering simplicity and brute force, a vessel designed to rely on raw power rather than refined aeronautical elegance. The intelligence briefs described it as a heavy, unsophisticated platform that prioritized ruggedness and operational durability over finesse or agility. They painted it as a tool relying on sheer weight and relentless operational availability, attributes that supposedly made it less a precision instrument and more a formidable sledgehammer in the hands of American bomber escorts. German pilots and engineers, with their tradition of deploying sleek, highly refined crafts such as the Messerschmitt Bf 109 or the Focke-Wulf FW 190, perceived the P-47 as an unrefined machine, almost a caricature of what a fighter should be. Their engineers prided themselves on designing aircraft that were finely tuned, precise instruments, refined through meticulous engineering and a focus on sharp maneuverability, maximum speed, and agility. The P-47, in contrast, seemed to embody brute strength and simplicity. Its influence on his cognitive landscape was profound, as Lerche prepared himself to scrutinize this strange foreign machine. As he approached, he was about to uncover a reality that would fundamentally challenge his understanding of what constitutes effective aircraft design. The briefing's description, a somewhat dismissive portrayal of the P-47 as a crude, brute force machine, was only a superficial observation. The truth, he was about to realize, was far more nuanced and potentially dangerous. Far from being a poorly engineered brute, the American P-47 Thunderbolt represented a different approach, a fundamentally practical and highly effective concept rooted not in individual pilot prowess, but in strategic industrial design. It was a machine built not for the typical fighter ace aiming to break records or perform spectacular maneuvers, but for the masses, for armies engaged in relentless, multi-front warfare. This aircraft was optimized for what could be described as mechanical mass production, an essential characteristic that made it a formidable weapon in total war. It was designed to be reliable, versatile, and operationally available in vast numbers. Its strength lay in its ability to sustain continuous combat, to overwhelm enemies through overwhelming numbers rather than through intricate tactics or exceptional pilot skill. It was a logistical behemoth on wings, capable of maintaining high operational readiness for days, weeks, and even months, thereby ensuring the relentless application of pressure on the enemy's defenses. In less than an hour and a half, Lerche would return to his quiet workspace, where he would carefully compose a detailed report. This document would likely be dismissed or shrugged off by many, later to be archived and ignored amidst the chaos of war. Still, history would eventually bear witness to the accuracy of his insights. His observations would turn out to be prescient. It would become apparent that Germany's philosophy of fighter design was rooted in the pursuit of individual excellence, crafting aircraft optimized for the skill of the pilot, for the fighter's sleekness and agility. Meanwhile, America's approach was fundamentally different, emphasizing industrial efficiency, mass production, and a pragmatic focus on operational dominance. In the broader context of total war, this distinction would prove to be decisive. While Germany continued striving for the creation of fighters that embodied personal mastery and technological refinement, the United States was constructing aircraft tailored for a war of attrition, machines meant to be produced in the thousands, to be used relentlessly, and to break the enemy's will through overwhelming economic and military might. This divergence in doctrine and design philosophy would shape the outcome of the conflict in profound and irreversible ways. Hans-Werner Lerche had been passionate about aviation almost since childhood. Born in the year 1916 in the town of Berlin, his fascination with flight emerged early on, which propelled him into the world of soaring gliders during the early 1930s. Despite his modest family background, his determined spirit and unwavering dedication allowed him to make rapid progress, building his skills piece by piece over the years. When Adolf Hitler rose to power and the German Reich initiated its clandestine rearmament efforts, opportunities that had previously been out of reach gradually began to open up for young Lerche. By the year 1939, he had established himself as a test pilot working for the Reich's Luftwaffe at a facility known as Rechlin, which functioned as the German equivalent of America's aircraft testing grounds or Britain's famous Braf Farnby. Unlike combat pilots who often specialized in flying one or two types of aircraft throughout their careers, Lerche's role demanded a broad skill set. He was the quintessential test pilot, flying a wide array of aircraft, from cutting-edge prototypes to wartime production models, including even enemy-possessed aircraft captured during clandestine operations. His logbook would eventually record the experience of going aloft in over 120 different aircraft types. A trained aeronautical engineer, his reports were renowned for their brutal honesty and technical precision. When an aircraft proved to be deficient in any aspect, he voiced his critique without hesitation. Conversely, when he recognized the superiority of an enemy design, he documented it comprehensively. This unwavering fidelity to truth and technical accuracy earned him both respect and some enemies within the Nazi administration. Officials who preferred optimistic assessments to justify ongoing projects often found his blunt reports unwelcome. Despite the discomfort it sometimes caused, Lerche's expertise was too valuable to dismiss or ignore. His assessments carried weight. If he declared an aircraft good or bad, decision-makers listened diligently, even if they sometimes disliked what they heard. The P-47 Thunderbolt that was now resting on the Rechlin tarmac held a particularly intriguing story. Its pilot, Lieutenant William Roach, was a member of the 358th Fighter Squadron within the 355th Fighter Group. On November 7th, in the midst of a mission to escort bombers, Roach had encountered unexpected weather conditions, bad visibility, and turbulent atmospheric conditions that had led him far off course. During this encounter, the entire crew found themselves in a dire predicament. Fuel supplies had been severely depleted because the diversions and adverse weather had caused delays and detours. In the chaos, the flight leader had been forced to make a crash landing on a nearby beach, with the aircraft skidding onto the sands in a controlled but impactful sequence. Meanwhile, another pilot, overwhelmed by the deteriorating weather, chose to bail out over the rough waters of the North Sea, abandoning his aircraft in a desperate attempt to save himself. These incidents altogether underscored the perilous and unpredictable nature of aerial combat and reconnaissance missions over enemy territory, especially under adverse weather conditions that could turn a routine escort into a harrowing ordeal. Only one aircraft managed to return to England, and even that achievement was by the narrowest of margins. Roach, having flown across the English Channel, believed he had spotted what appeared to be an airfield nestled somewhere in the southern part of England. Confident that he could land safely, he descended carefully, guided by the vague silhouette of a ground vehicle ahead, which he followed to what seemed to be a designated parking area for aircraft. Once he brought his aircraft, affectionately nicknamed Beetle, to a halt and shut down his engine, it was only then that an overwhelming and horrifying realization dawned upon him. The location he had presumed to be in England was not England at all. Instead, he found himself within the confines of a German Luftwaffe base located in what appeared to be a place labeled simply as K, in France. The sudden appearance of armed German soldiers approaching him, weapons in hand, confirmed beyond any doubt that he was now a prisoner of war. The aircraft he had been flying, a product of Allied engineering, was no longer his. It had become German property. The swift reaction of the Luftwaffe had been impressive. While Allied fighters aggressively patrolled the skies, strafing high-value targets with relentless precision, the captured Beetle was quickly flown inland to a location called Reclon before any American or British fighters could intercept and destroy it. Today, it sits in quiet anticipation, awaiting evaluation and assessment by German engineers. It is painted with Luftwaffe camouflage and marked with the code T9+FK, a designation that signals its connection to the renowned Circus Rosarius demonstration unit, famous for its showcasing of captured aircraft and innovative tactics. Meanwhile, Lerche, a pilot who had heard the dismissive comments from fellow pilots, also observed the aircraft closely. Many of his peers had derided the P-47 Thunderbolt as a joke. To them, it was too heavy, too large, and too distinctly American in design philosophy. They viewed it as embodying everything they considered wrong about American aircraft engineering: crude, unrefined, heavily reliant on massive engines to compensate for less than ideal aerodynamics. These opinions were widespread among German pilots, who often viewed Allied aircraft with a mixture of disdain and skepticism. However, Lerche had learned through experience that first impressions could be deceptive. He had flown enough captured Allied aircraft to recognize very quickly that the engineers behind their designs were highly skilled and capable. If the Americans and British had chosen a certain design path, there were often solid reasons behind it, reasons rooted in different priorities, technological constraints, or strategic doctrines. His task, therefore, was not to judge hastily but to understand these decisions thoroughly. As he approached the aircraft, Beetle, he couldn't help but notice its impressive size. The radial engine attached to it was enormous, a true giant among engines, and the fuselage was constructed in a cylindrical, barrel-like shape that wrapped around this power plant. The landing gear, thick and robust, hinted at the aircraft's heavy-duty construction and capacity to endure rough landings and stresses. Everything about the aircraft conveyed heaviness and strength, a stark contrast to the sleek, streamlined fighters of the German Luftwaffe, which were optimized for agility, speed, and performance. In comparison, Beetle seemed almost unwieldy, as if it had been designed by shipbuilders rather than aeronautical engineers, clumsy, rugged, and built for resilience rather than elegance. Lerche proceeded with a detailed walk-around inspection, carefully examining the aircraft's construction. It became immediately obvious that the manufacturing quality was high. The welds along joints were smooth and precise, the gaps between panels were uniform and tight, and the materials used throughout the plane were of high-grade quality. This was no crude assembly or hasty production. This was sophisticated mass manufacturing, executed with a clear mastery that indicated significant expertise. Such attention to detail and quality control was particularly impressive considering the immense pressures faced by German factories as the war dragged on and resources became increasingly scarce. Maintaining such tight tolerances was a challenge, yet this aircraft appeared to adhere to them meticulously. Lerche then clambered into the cockpit, an environment that, upon initial inspection, was strikingly large compared to the cockpits of German fighters like the Messerschmitt Bf 109. The cockpit was enormous, spacious enough for a pilot to move comfortably and avoid feeling cramped. For a German pilot trained in the tight confines of the Bf 109, this would have certainly come as a surprise. The difference was stark. While the German aircraft prioritized compactness to enhance maneuverability and reduce weight, the U.S. design favored comfort and pilot ergonomics, especially for long missions. As Lerche settled into the pilot's seat, he quickly understood why German pilots had often complained about the cockpit dimensions. In the Bf 109, they had to crouch and contort themselves constantly, often banging their heads against the canopy or struggling to access essential instruments quickly. The cockpit's cramped interior made long flights physically exhausting, and becoming a pilot often meant accepting discomfort as a necessary compromise for superior performance. In contrast, the P-47's cockpit was a model of comfort and practical usability. The seat was thickly padded, designed to reduce fatigue over extended flights. There was ample space to move, to stretch, and to shift positions, making long hours in the air significantly more bearable. The canopy was high and expansive, providing exceptional visibility in all directions, a vital feature for combat or reconnaissance missions. This design reflected a different engineering philosophy, one that prioritized pilot ease and operational comfort, even if it meant sacrificing some of the compactness and agility that German fighters emphasized. Everything in the surrounding environment was conveniently within arm's reach, requiring no strenuous effort or awkward movements. It was as if every essential tool, every control, and every instrument was perfectly positioned to be accessible at a moment's notice, creating an atmosphere of efficiency and ease. With this initial comfort established, Lerche turned his attention to the intricate array of instruments and control panels before him, beginning a careful and systematic examination. As he scrutinized the various gauges, switches, and displays, he suddenly encountered something truly remarkable, something that stood out from the usual, ordinary instrumentation. The instrument panel caught his eye because it incorporated a sophisticated system of color coding, a feature designed for quick and intuitive interpretation. Specific regions on the panel were marked either in red or green, clearly indicating the acceptable ranges for engine operation. These colors served as visual cues, allowing any pilot to instantly assess the engine's status at a simple glance, without the need to decode complex numerical values or interpret detailed readings. Green zones signified normal, safe operating conditions, while red zones unmistakably flagged danger or trouble spots. This color-coded system was remarkably universal and straightforward, relying on the intuitive human understanding of colors rather than language or technical literacy alone. Lerche quickly realized the significance of this design choice in a broader operational context. According to intelligence reports he had studied beforehand, American fighter pilots came from a variety of nations, each with different linguistic backgrounds. Among these were pilots from France, Poland, and even individuals with limited English skills. Such diversity posed a challenge. A standard instrument panel with only textual information in English could potentially hinder safe operation for pilots unfamiliar with the language. The implementation of this color coding meant that a pilot who struggled with English could still confidently operate the aircraft without risk, simply by understanding the meaning conveyed through the colors. Green, universally associated with good or safe, indicated that everything was functioning correctly. Conversely, red, universally recognized as danger or warning, signaled that a problem or critical issue was present. This approach was nothing short of brilliant, not merely from an engineering perspective, but from an operational, practical standpoint. Unlike traditional gauges used in German aircraft, which demanded precise comprehension of particular limits, thresholds, and measurement values, the American system prioritized ease of use and human factors. The P-47 Thunderbolt was designed so that even a pilot with minimal training, perhaps just enough to recognize the meaning of colors rather than interpret detailed numerical data, could operate the aircraft safely and effectively under battle conditions. This was not a haphazard or crude engineering solution. Rather, it was a deliberate, inclusive design strategy that acknowledged the realities of wartime flight, where swift decision-making and instinctive responses could mean the difference between life and death. Continuing his inspection, Lerche observed that the control layout itself was thoughtfully organized and highly logical. The placement of controls was ergonomic. Every element seemed deliberately positioned to facilitate quick recognition and ease of manipulation. The throttle, mixture control, and propeller pitch adjustment were all grouped together on the left side of the cockpit, creating a natural cluster that pilots could access without confusion. Meanwhile, the controls for the fuel system were clearly labeled with unambiguous indicators, minimizing the chance for error in stressful situations. Everything appeared designed with user-friendliness at its core, emphasizing simplicity and quick accessibility. In stark contrast, German fighter aircraft were generally built for pilots with considerable expertise. For instance, the famous Bf 109 was notorious for its demanding handling characteristics, especially during takeoff and landing phases. Its narrow landing gear made ground control tricky, often resulting in ground loops, spins caused by the aircraft's unstable ground handling dynamics. Mastery of such aircraft required not only skill, but also considerable experience and finesse. The Germans accepted these demands because their rigorous training programs produced highly skilled pilots capable of handling such challenging machines. But by late 1943, it was clear to many observers, including Lerche, that the Luftwaffe's extensive training system was beginning to collapse under the weight of wartime shortages. Fuel shortages, in particular, had a profound impact. They meant that newly trained pilots had very limited time in the air before being thrown into combat, often with minimal practice or real-world experience. The elaborate training structures that had previously produced a steady flow of expertly skilled German pilots in 1939 and 1940 had, by this point, all but disintegrated. Germany found itself in a situation where it needed aircraft that even novices could fly without risking catastrophe, planes that would not require deep expertise to operate safely. Concurrently, however, the German war effort still aimed to produce aircraft suited for their top aces, fighters that could be expertly handled in the hands of seasoned pilots, and that could dominate the skies in the hands of experienced flyers. Lerche then moved on to examine the pre-flight checklist, which was presented in a manual that was both clear and thorough. Every step was meticulously outlined, with detailed instructions designed to guide the pilot through the entire process. Unlike the American manuals, which assumed that the pilot would be well-trained and perhaps familiar with basic procedures, the German manuals seemed to presume a level of expertise, leaving out detailed explanations that might be needed by someone less experienced. In contrast, American manuals adopted a more inclusive approach, assuming that some pilots might have limited knowledge and therefore providing extensive, step-by-step guidance for each procedure. He proceeded to start the engine, observing as the Pratt & Whitney Armanus 2800 double Wasp roared to life. The sound was distinctive, a deep, powerful growl that resonated through the cockpit with an unmistakable presence. As the engine warmed and settled into operation, Lerche noted something that would repeatedly surface as a key point in his assessment, an aspect that he would come to recognize as a hallmark of American aircraft performance. The engine ran incredibly smoothly, with a refined and elegant consistency that bespoke reliable engineering. It was a beautiful, almost rhythmic hum, devoid of vibrations or irregularities, and without any signs of distress or abnormal sounds. Such an engine was capable of operating without fuss or fussiness, demonstrating a level of mass production craftsmanship that was difficult for Germany to match. Having seen enough, Lerche appreciated the significance of this smoothness. It was a testament to the high-quality manufacturing processes employed by American industry, mass production techniques that ensured each engine, regardless of batch, met rigorous standards. These engines, produced in vast quantities, could be relied upon for steady and dependable operation even in the stressful conditions of aerial combat. And in the context of wartime, where supply chains and quality control could be unreliable, the consistency and reliability of American aircraft engines stood as a striking achievement, one that set a standard other nations could only aspire to replicate. Constructing a single, perfectly engineered engine within the controlled environment of a laboratory was undeniably a feat of precision and skill, requiring meticulous attention to detail and advanced technical expertise. However, the real challenge extended far beyond this initial success. Manufacturing thousands of these carefully crafted engines, each one to the same exacting standard of reliability and performance, was an entirely different endeavor altogether. It demanded not only consistency in production, but also an unwavering quality assurance process to ensure that every engine would perform flawlessly under various conditions, time after time. Once the Lerches received the official clearance to proceed, they taxied their aircraft towards the runway, preparing for a new chapter in their testing phase. Here, another essential discovery unfolded. The sturdiness and design of the P-47's landing gear revealed itself to be a significant advantage. Its broad, robust construction was specifically engineered to withstand rough handling and hard landings. As the tail wheel locked securely into position, it kept the aircraft tracking straight and true, which greatly simplified the taxiing process. With excellent visibility from the cockpit and a feel of remarkable stability in the hands, the pilot could maneuver with confidence. In stark contrast, operating a Bf-109 on the ground was a considerably more challenging task. The narrower landing gear on the German fighter made ground handling a persistent struggle because it lacked the stability of a more robust design. Pilots frequently grappled with poor visibility over the nose, which compounded the difficulty, leading inexperienced pilots to sometimes ground loop their aircraft unintentionally during taxi or landing procedures, often resulting in damage, even in the absence of enemy fire or combat. The Luftwaffe accepted these inherent ground handling issues as the unavoidable trade-off for the high performance their fighters offered. Designed with the realities of battlefield conditions in mind, the P-47 was built to be operated from rugged, makeshift forward airfields by pilots of varying experience levels. Its reinforced landing gear could absorb the shock of abrasive landings and rough terrain, enabling pilots to recover from hard landings with a reduced risk of structural damage. The aircraft's predictable ground handling characteristics meant fewer accidental mishaps and contributed to overall operational safety. In his memoirs, Lerche later recounted an incident where he had nearly ground-looped the plane after forgetting to lock the tail wheel, a close call that he managed to correct just in time. The fact that he could intervene successfully demonstrated the forgiving nature of the aircraft's design, something that would have been nearly impossible with a more temperamental fighter like the Bf-109, which demanded more precise handling and offered less margin for error. Lerche lined up the aircraft on the runway, ready for takeoff, and advanced the throttle gradually. The power increase was immediately noticeable, impressive, and commanding. The massive engine pushed this heavy fighter forward with a substantial force, highlighting its extraordinary torque and raw power. The takeoff run, while longer than that of a typical German fighter, was still within reasonable limits. As the aircraft gained speed and lifted off smoothly from the ground, Lerche retracted the landing gear to its proper position, streamlining the aircraft for its ascent. Climbing steadily to altitude, Lerche began assessing the aircraft's handling at various speeds and configurations. He observed that the P-47 did not possess the agility typical of German fighters. It didn't turn as sharply or respond as instantaneously in the cockpit. It was clear that its design prioritized stability, predictability, and reliability over lightning-fast maneuvers. While it lacked the fiery agility of a Bf-109 or FW-190, it exhibited a steadiness that inspired confidence, especially for pilots operating under challenging conditions. Eager to understand its full capabilities, Lerche experimented with deploying the flaps once at a safe altitude. As he had previously noted in his memoir, the hydraulic system operated smoothly and seamlessly, with no quirks or unpredictable behaviors. Every component and system responded precisely as conceived. No unexpected surprises, no systems requiring delicate management or adjustments. This consistency was beginning to reveal an important pattern. The P-47 was not meant to be the most agile fighter in aerial combat. It was not aimed at achieving top speed at low altitude nor excelling in traditional dogfighting tactics. Instead, its strength lay in its overall reliability, its ability to perform reliably across various systems, and its forgiving nature, which made it forgiving of pilot errors and mistakes. In comparison to the temperamental thoroughbreds of the German Luftwaffe, known for their responsiveness and sharp handling, but also their unpredictability, the P-47 represented a true workhorse, an aircraft designed for durability and dependability in the harsh realities of industrial warfare. Lerche was beginning to grasp a fundamental truth. In the grand scheme of wartime production and combat efficiency, the workhorse had the advantage. The aircraft's resilience and steady performance made it invaluable. At higher altitudes, above about 15,000 feet, the turbo supercharger came into its own. The aircraft accelerated smoothly and maintained consistent power where German fighters found their engines struggling in the thin atmosphere. Its diving performance was equally impressive, with a roll rate that, considering the size and mass of the aircraft, was remarkably good. During a flight lasting approximately an hour and a half, Lerche pushed the Thunderbolt through a series of maneuvers, testing its limits and capabilities. Throughout every stage of this flight, the aircraft never delivered a negative surprise. Everything functioned exactly as it was designed to. The engine chugged along without faltering, the controls remained responsive, and all systems operated without fault. This consistent performance reaffirmed for Lerche a deeper and more profound understanding that the P-47 was more than just a fighter. It was an embodiment of reliability, resilience, and design integrity. Its forgiving nature and dependable systems meant that even in the unforgiving environment of aerial combat, the pilot could trust the aircraft to respond predictably, to endure challenging conditions, and to ultimately serve as a dependable partner in the dangerous missions that lay ahead. The P-47 Thunderbolt was not initially conceived as the most agile or fastest fighter aircraft in the skies. Instead, its fundamental purpose was to serve as the ultimate operational fighter, an aircraft built to withstand the rigors of prolonged combat missions, to perform reliably under a wide range of conditions, and to maximize its effectiveness in real-world wartime scenarios. There was a significant distinction between designing a fighter to excel in ideal, controlled conditions and creating one that could consistently perform well across the unpredictable realities of battle, and that difference was, quite frankly, profound. German engineers, for their part, approached aircraft design with an emphasis on peak performance, striving to produce fighters that could outmaneuver opponents in tight dogfights and achieve superior aerodynamic efficiency. Their goal was to craft machines optimized for maximum speed, agility, and sharp handling, vehicles that, under perfect conditions, might outrun or outfight their adversaries. Conversely, American engineers prioritized durability, endurance, and operational resilience. They tailored their designs to ensure that their aircraft could sustain prolonged missions, survive battle damage, and be maintained effectively under field conditions, even when faced with the chaos of wartime environment. Imagine a perfectly maintained German fighter, like a pristine Bf-109, being flown expertly. Under such ideal circumstances, it might outperform a P-47 in a dogfight, zipping through the air with agility and speed. Yet, the practical reality was quite different. How often was a German fighter aircraft kept in immaculate condition? Quite rarely, in fact. The demanding maintenance schedules, availability of spare parts, and constant combat were meant that these aircraft frequently operated under less than ideal conditions. How often were pilots in perfect form, exceptionally trained, rested, and free of stress or injury? The answer, again, was infrequently. Pilots faced fatigue, stress from ongoing combat, even injuries that hampered their reflexes. Furthermore, how often could ground crews perform flawless, precise maintenance in the field, often under enemy fire, with limited tools, and under time constraints? Not very often. The design philosophy behind the P-47 incorporated all these realities. It was built assuming that maintenance would be performed by mechanics of varying skill levels, working with parts that could come from different batches, all under the unpredictable chaos of wartime conditions. The aircraft had to be forgiving of imperfect repairs and quick fixes. It was designed to operate reliably under conditions where pilots might be exhausted, inexperienced, or wounded, and where aircraft might sustain battle damage yet still have to fly out of danger zone. Every decision in its engineering, the robust structure, the forgiving handling characteristics, the intuitive control layout, the dependable engine, made sense once this operational philosophy was understood. The P-47's sturdy construction ensured longevity. Its forgiving handling made it accessible to pilots of all skill levels. The intuitive controls reduced the training time needed for new pilots, and its reliable engine minimized unexpected failures during critical moments. All these features served the central goal of maximizing operational availability, keeping fighters in the air longer, ready to engage, respond, and survive. One such aircraft, called Lerche, had returned from a sortie and safely executed a straightforward landing. His aircraft taxied smoothly back to the hangar, aided by its rugged landing gear that absorbed the shock of touchdown with ease. Once parked, Lerche powered down the engine and was quickly surrounded by ground crew members, all eager to hear his assessment of this seemingly grotesque American fighter, an aircraft that looked brawny and formidable, but perhaps not elegant or sleek. Lerche stepped out, paused for a long moment while gazing at the aircraft, seemingly studying it with quiet respect. Then, unexpectedly, He spoke words that caught everyone off guard. He declared, quite frankly, "It is the best designed operational fighter I have ever flown." The mechanics looked at him, clearly puzzled by this statement. They saw a massive, bulky, and somewhat awkward-looking aircraft. To their minds, it seemed heavy, clumsy even, and certainly not graceful. How could such a machine be the best designed? Lerche's explanation clarified their confusion. He clarified that his assessment was not based purely on raw performance, speed, maneuverability, or aesthetic elegance. Instead, he emphasized, it's not designed for performance, it's designed for operations. And there is a crucial difference. The aircraft's design prioritized operational effectiveness, its ability to perform reliably in the real, often unforgiving conditions of combat missions. That very evening, as dusk settled and the hangar lights flickered on, Lerche settled at his desk to compose a detailed technical report. For him, this task was more than a routine requirement. It was a vital part of his duty. Piloting the aircraft provided valuable insights, but understanding what the aircraft represented in a larger strategic context, how it could influence the course of battles and overall war efforts, was equally essential. He carefully structured his report into several key sections to make his evaluation as clear and comprehensive as possible: performance metrics, handling characteristics, the system features, and a strategic assessment. In the performance section, he methodically documented facts about the aircraft's speeds, climb rates, and flight behavior. For instance, he noted that the P-47 was notably fast at high altitudes thanks to its turbo supercharger, but somewhat slower at lower altitudes, with excellent dive performance. Its ability to turn was adequate, but did not shine compared to more agile fighters. Still, its climbing capabilities were impressive, and at high altitude, the aircraft performed exceptionally well, an important factor during bomber escort missions. Moving into the handling section, Lerche observed that the aircraft exhibited stable, predictable flight characteristics, making it easier for pilots to control even in turbulent conditions. The aircraft handled well from the ground, with forgiving responses that reduced the risk of stalls or spins, especially for less experienced pilots. Visibility from the cockpit was good enough for combat scenarios, and the cockpit itself was designed for comfort during long missions, helping pilots endure extended periods in the air without undue fatigue. In the systems section, he detailed the aircraft's instruments, color-coded displays that aided quick interpretation of vital information, an intuitive control layout that minimized pilot error, and the robust construction of key components that enhanced longevity and ease of maintenance. The engine was smooth and reliable, minimizing unexpected failures that could jeopardize missions. Finally, in the most insightful part of his report, his strategic assessment, Lerche penned observations that would prove surprisingly visionary. Despite the fact that his report might be filed away and largely disregarded, he expressed a fundamental truth. The P-47 Thunderbolt embodied a distinctly different design philosophy from that of its German counterparts. Whereas German fighters excelled in agility and sheer speed, the American aircraft prioritized operational resilience, durability, and practicality in the harshest conditions. These core principles, he argued, made the P-47 an indispensable asset in the broader scope of wartime strategy, an aircraft built not merely to win quick dogfights, but to sustain the larger campaign and ensure victory through endurance. German fighter aircraft have been meticulously engineered and refined over the years to achieve the highest levels of peak performance, a pursuit that inherently assumes the presence of highly skilled pilots and rigorous, continuous maintenance routines. These aircraft are designed with a focus on maximizing individual machine capabilities, often emphasizing maximum speed, agility, and raw power, but this often comes at the expense of simplicity, durability, and ease of prolonged operational use. In stark contrast, the iconic P-47, commonly known as the Thunderbolt, was deliberately crafted with a different set of priorities in mind. Its core design philosophy centered around operational dependability and consistent performance during extended missions, accepting that the pilots flying it might not be experts, and that maintenance conditions at remote or wartime airfields would be less than ideal. This aircraft was purposely engineered to be operated in large formations, by crews with a broad spectrum of skill levels, and in environments where field repairs and improvisations were commonplace. Its handling characteristics were intentionally forgiving. The designers wanted pilots of varying experience to fly it confidently without the constant hazard of accidents caused by difficult or unpredictable control responses. Such a design choice significantly contributed to reducing the number of crashes and mishaps during hectic combat scenarios. Additionally, the fighter's robust structure meant that a higher proportion of aircraft could be expected to survive missions and return home even if subjected to enemy fire. The engine selected for the P-47 proved to be exceptionally reliable, which translated into longer durations of operational readiness and fewer unplanned maintenance stops. Its control layout was made intuitive and straightforward, ensuring that pilots could learn the system quickly, thereby shortening the training period and expanding the pool of qualified pilots. Most importantly, the underlying principle guiding every design decision was not to push the aircraft to the absolute limits of performance in a static sense, but rather to ensure that it could sustain a high operational tempo over extended periods. The emphasis was on producing a fighter that could be counted on day after day, mission after mission, rather than simply achieving maximum speed or agility for brief encounters. The American approach, therefore, was not to construct the most advanced or fastest fighter, but to develop the most effective, reliable, and mass-producible aircraft that could be deployed in overwhelming numbers. This philosophy enabled them to assemble fleets of fighters that, while perhaps not the most refined in individual performance, could be operated seamlessly at a scale that neutralized many of the advantages held by their adversaries. Lerche paused thoughtfully as he contemplated how best to express his final assessment. He understood that his conclusions might provoke controversy, or even pose certain risks if they were not carefully presented. Nonetheless, he believed that presenting an unvarnished, precise evaluation was of greater importance than avoiding potential discomfort or dissent within the command structure. After some reflection, he summarized his findings. The P-47 was not the result of crude or rudimentary engineering, but rather the product of sophisticated operational design. It embodied an approach that prioritized practical field performance and logistical sustainability. By contrast, Germany continued to develop fighters aimed at achieving individual excellence, aircraft that often pushed the limits of aeronautical mastery, but that might be less forgiving in the face of operational challenges. In essence, the United States built fighters for what could be termed industrial war, the kind of conflict that relies heavily on mass production, easy maintenance, and operational efficiency. If the Americans could deploy hundreds, if not thousands, of such aircraft painted in a similar pattern, flown by pilots who were adequately trained but not necessarily expert aces, then their numerical superiority would translate into a stark advantage on the battlefield. The sheer volume, combined with the high operational availability of their fighters, could negate any qualitative superiority that German aircraft might still possess. Consequently, he recommended that Germany's fighter design philosophy urgently incorporate operational reliability as a core goal from the outset, rather than relegating it to a secondary or tertiary concern. Without such an adjustment, Germany risked being overwhelmed in a prolonged attrition war, one where the ability to keep aircraft flying and available over extended periods was crucial. If their fighters were not built with ease of repair, durability, and consistent performance in mind, the vast American industrial capacity could simply outproduce and outlast them. Having completed his analysis, Lerche signed the report and submitted it through the proper channels, confident that the insights contained within it were necessary and truthful. The document made its way up the hierarchical command structure for review. It was read attentively, discussed among various officers, and then ultimately filed away, its conclusions dismissed by some as overly pessimistic and perhaps too critical of American manufacturing approaches. The prevailing belief at the time was that the P-47 was still a relatively rough American design, not yet matching the finesse and superiority of German fighters. Consequently, the dominant narrative was that German aircraft remained superior in quality and design. So, the discussion was considered closed. However, reality began to unfold rapidly and proved Lerche right almost immediately. By the beginning of the year 1944, P-47 Thunderbolts started appearing over German skies in unprecedented numbers. These formidable aircraft escorted American bombing formations as they penetrated deep into the heart of Germany, supporting strategic raids that caused significant destruction. The numbers grew day after day. Sorties became a relentless stream of missions, with no sign of waning. German fighters intercepted these formations regularly and sometimes succeeded in shooting them down, yet the next day brought even more P-47s, always more to replace those lost. Luftwaffe pilots quickly found themselves grappling with a frustrating reality. They would damage or even shoot down P-47 fighters that seemed to be otherwise unscathed and still capable of flying home. American pilots, in turn, were often able to eject from their wrecked fighters and then continue flying in fresh aircraft the very next day. On some occasions, they would shoot down a German pilot and then encounter a different American pilot, flying a new P-47, in the skies that very next day. The American supply of these fighters appeared inexhaustible, almost as if they had been produced in a never-ending stream, fueling an operational tempo that seemed impossible to match. Meanwhile, the German war effort in terms of fighter aircraft was faltering. The relentless Allied bombing campaigns repeatedly disrupted factories, limiting their capacity to produce new aircraft and replace lost ones. Material shortages became increasingly acute, forcing difficult decisions and compromises in manufacturing quality and quantity. The supposed high standards of German aircraft maintenance and production suffered as skilled workers were conscripted or drafted into other roles, and their replacements were often less experienced or lacked proper training. The use of forced labor was a tragic necessity, but it inevitably contributed to a decline in aircraft quality. In consequence, many aircraft that should have been reliable in combat were instead plagued with failures. Engines failed prematurely, sometimes during crucial moments, and various systems malfunctioned unexpectedly. These issues widened the gap in operational availability, meaning fewer aircraft were ready and able to fly at any given time. Even if the German aircraft fleet boasted numerically larger figures on paper, the actual number of aircraft actively and reliably engaged in combat was dwindling. By contrast, American units maintained superior operational readiness, with their aircraft meticulously designed and manufactured to withstand the rigors of ongoing warfare, enabling them to keep flying at a higher rate of availability day after day. Lerche continued his demanding and intricate work for the German military aviation organization, known as Rechlon, dedicating himself tirelessly to testing and evaluating a wide array of captured aircraft. His routine involved flying additional enemy planes, meticulously examining their capabilities, and drafting detailed reports to capture every nuance of their design, performance, and operational reliability. Among these aircraft was a captured P-51 Mustang, an American fighter that had earned a formidable reputation. As Lerche piloted this aircraft, he couldn't help but be struck by the remarkable combination it offered, an impressive balance between extended range and high performance. Its design facilitated long-range missions without sacrificing agility or speed, features that truly captivated him. In the course of his evaluations, he also took to the skies in several other renowned fighters, including British Spitfires, Hurricanes, and various Soviet-manufactured planes. Each flight, each assessment, reinforced a crucial and consistent conclusion that the Allied aircraft's primary advantage lay in their operational reliability and sustainability rather than their raw speed or maneuverability alone. Through these detailed examinations, Lerche became increasingly convinced that the core strength of the Allied air forces rested in their ability to keep aircraft flying repeatedly over long periods. This operational endurance was the keystone of their air strategy. For instance, the P-47 Thunderbolt, affectionately nicknamed the Beetle, which Lerche, another pilot, had previously flown, eventually found its way into the hands of Zirkus Rosario, a special unit within the Luftwaffe dedicated to demonstration and reconnaissance. This unit specialized in traveling to frontline fighter bases carrying captured Allied aircraft, an unconventional yet revealing method of reconnaissance and education. Their purpose was twofold: to showcase German pilots what the enemy's aircraft could do and to analyze their strengths and vulnerabilities in detail. Ironically, this approach meant that German pilots received comprehensive briefings about the capabilities and weaknesses of aircraft such as the P-47. They learned the ins and outs of its performance, its operational advantages, and its shortcomings. Yet, despite this extensive knowledge, the German aircraft industry seemed unable, or perhaps unwilling, to incorporate this new intelligence into their own aircraft designs. The Germans did not adapt or improve their planes to counter the P-47's advantages, leaving their fighters potentially at a tactical disadvantage. The war, relentless and unyielding, continued to drag on into the late months of 2044. By then, the Luftwaffe's once formidable strength was faltering, and it was clear that the organization was collapsing from within. The reasons weren't due to a lack of courage or skill among German pilots, who fought valiantly and often with remarkable bravery. Instead, the downfall stemmed from the collapse of the industrial backbone that supported their war effort. Factories that had once churned out aircraft at an enormous pace could no longer keep up. Many planes sat idle on airfields, grounded because of fuel shortages, their engines silent, their wings unmoving. Training new pilots faced the same obstacle. Insufficient fuel meant minimal flight hours, and promising new pilots received only fragmentary instruction before being sent into combat. Meanwhile, the supply of spare parts had become critically scarce. Every component, every engine part, every piece of essential equipment was in limited supply and often impossible to replace promptly. The very advantage Lerche had identified as the cornerstone of the American military effort, the ability to sustain large-scale, reliable operations, was entirely absent from the German side of the war. Their machinery began to break down more frequently, their aircraft remained grounded more often, and their ability to project power was steadily eroding. Despite these hardships and the ever-encroaching defeat, Lerche managed to survive the war. His exceptional skill as a test pilot, combined with an innate sense of caution and precision in his flying, meant he never experienced a serious crash or caused significant damage to an aircraft over his entire career. This extraordinary record was all the more impressive considering that he had flown more than 120 different types of aircraft, many of which were captured enemy planes. Most of these aircraft had come to him without manuals, technical documentation, or any prior familiarity, yet he managed to master them quickly and evaluate their true capabilities effectively. After the surrender of Germany, Lerche was subjected to detailed interrogations by Allied technical intelligence officers. They were eager to learn firsthand from him about his experiences flying and assessing captured Allied aircraft, as his insights carried substantial value. His reports, stored in German military archives, provided a wealth of information and formed a basis for the Allies' understanding of enemy technology. During one such discussion, the question was posed, based on your evaluations, do you believe Allied aircraft are genuinely superior in operational terms, or is it merely a matter of performance specifications? Lerche, after some reflection, expressed his core conclusion very clearly, that the true advantage of American aircraft was rooted not in raw speed or aerodynamic finesse, but in their operational design philosophy. An American officer present inquired with surprise, "That's an unusual assessment." Lerche nodded in acknowledgement before elaborating. "Indeed, this is the most significant insight. Your pilots weren't necessarily better than ours, nor were your planes faster or more maneuverable in a dogfight. The critical difference lay in your ability to keep more aircraft flying longer, more reliably, and more repeatedly. You could train more pilots efficiently and, most importantly, sustain large-scale operational campaigns without the catastrophic failures that hampered our efforts. That resilience, your operational sustainability, was the decisive factor." He further explained whether this was apparent when he flew the P-47. "Absolutely," he replied without hesitation. "Once I understood the fundamental philosophy behind its design, everything became clear. These aircraft weren't built solely to dominate in aerial combat through superior agility or speed. They were engineered for endurance, for long, continuous deployments. The cockpit was spacious and comfortable, allowing pilots to endure lengthy missions of up to 8 hours without severe fatigue. The handling was forgiving, leading to fewer accidents and more intact aircraft returning from missions. The engine was designed and tested for reliability, reducing downtime for repairs. And the aircraft's robust construction meant that even when damaged in battle, they often made it back home, reparable and ready for subsequent missions. Lerche paused and then asked, "Did the German leadership truly understand this fundamental difference?" His tone was marked by a bitter edge, revealing a mixture of irony and disappointment. "I filed my report," he added quietly. "My conclusion was that I had been somewhat demoralized by the strange experience of flying enemy aircraft, which clouded my judgment and led me to believe that my assessments might be biased." The official stance was that German engineering was superior. They claimed that American engineering was crude and unsophisticated. But the reality was much more complex, and perhaps more revealing. In the end, Lerche saw the true strength of the Allied efforts not merely in individual aircraft's technical statistics, but in the overarching operational philosophy that prioritized endurance, reliability, and sustainability, qualities that ultimately tipped the balance in their favor during the bitter and prolonged conflict. This was the officially held stance at the time, and any evidence or arguments that challenged this prevailing view were often dismissed or ignored without due consideration. One might wonder whether, had Germany embraced the same American design philosophy and strategic approach to aircraft development, the outcome of the war could have taken a different turn. Lerche pondered this question with careful thought and a sense of critical analysis. By the year 1943, it became evident that such a change in philosophy would unlikely have significantly altered the course, primarily because Germany's industrial capacity was simply not on par with that of the United States or even the Soviet Union, regardless of the underlying design principles applied. Nonetheless, if the Germans had placed greater emphasis on operational reliability and durable performance from the very inception of their aircraft programs, it stands to reason that their fighters would have demonstrated greater effectiveness across the entire span of the conflict. Throughout the war, Germany suffered substantial losses not only because of enemy action but also due to a high rate of aircraft accidents, mechanical breakdowns, and maintenance-related failures that could have been mitigated or even prevented through more thoughtful, resilient design choices. The interrogation reports revealed a striking pattern among the engineers and technical personnel. Lerche discovered that he was far from the only German expert who recognized and acknowledged the engineering advantages enjoyed by Allied aircraft. Many had meticulously compiled reports outlining these discrepancies and weaknesses, and numerous others had offered recommendations to address these issues. Yet, almost all such suggestions had been systematically dismissed or ignored, precisely because their conclusions clashed with the deeply ingrained Nazi ideology that German technological and military superiority was a given, unchallengeable, and absolute. The stark reality was reflected in the final production figures, which told a compelling story of disparity. For example, the United States produced over 15,600 P-47 Thunderbolt fighters during the entire war period. During peak manufacturing times, this formidable aircraft was rolling off the assembly lines at an astonishing rate, approximately one Thunderbolt every single hour without pause. In stark contrast, Germany managed to produce only around 36,000 fighters of all types and configurations combined across the entire duration of the conflict, and its production was constantly hampered by relentless Allied bombing campaigns that targeted factories and transportation hubs. More consequential than sheer numbers was the operational readiness and combat sustainability of these aircraft. American warplanes consistently maintained higher rates of being available for missions when compared to their German counterparts. To illustrate this point, a typical American unit equipped with 100 P-47 Thunderbolts might have approximately 85 to 90 aircraft ready and operational on any given day, despite ongoing missions and maintenance requirements. Conversely, a German unit of similar size, with the same number of fighters, might have only about 60 or 70 aircraft available at any moment, as the remainder were often grounded for repairs due to shortages of spare parts, fuel, or routine maintenance. This multiplication of disparity created a devastating advantage. When you combine the higher production quantities with better operational reliability, which translates into higher availability rates, and superior endurance and sustainability, the result was a form of overwhelming numerical superiority achieved at the decisive points of contact on the battlefield. In his later years, Lerche dedicated himself to writing a detailed memoir titled Luftwaffe Test Pilot, a book in which he recounted his experiences flying captured Allied aircraft during World War II. His memoir provided readers with vivid, intricate accounts of what it was like to operate a wide variety of aircraft, ranging from the formidable B-17 Flying Fortress bombers to the agile P-51 Mustang fighters. Among the many technical insights he offered, his evaluation of the P-47 Thunderbolt was particularly notable. He included nuanced observations about its design and performance, culminating in his famously quoted preference for its spacious, comfortable cockpit compared to the cramped and less user-friendly cockpit of the Messerschmitt Bf-109. What elevates Lerche's story beyond mere anecdote is the fact that he was not just a pilot, but also a trained engineer and experienced test pilot capable of analyzing aircraft beyond surface appearances. His ability to interpret and understand what he observed gave him a distinctive perspective. He appreciated what made the aircraft successful or problematic, not only based on surface-level impressions, but by understanding the design choices and their broader implications. This skill allowed him to assess why certain features were incorporated, what technological philosophies they reflected, and ultimately, what those philosophies revealed about the industrial and military mindset behind their development. The aircraft he flew in November of the year 1943, the P-47 Thunderbolt, stood for more than just a single captured fighter. It embodied a vastly different approach to warfare, strategy, and industrial philosophy. Germany fought World War II as if it were still rooted in the lessons of World War I, where individual heroism, technological breakthroughs, and superior aircraft could determine the fate of battles. The German approach placed immense faith in the excellence of individual machines, expecting that if their fighters performed flawlessly, victory was assured. When the Bf-109 and Fw-190 were operating at their peak, they were truly exceptional aircraft, designed with meticulous craftsmanship and capable of impressive feats of agility and power. Yet, despite their engineering brilliance, these fighters often struggled under the weight of overwhelming logistical and industrial limitations, something that the American war effort, driven by relentless industrial output and a strategy of sustained operations and overwhelming numbers, was able to leverage to its advantage. Lerche's reflections shed light on this fundamental difference in military philosophy. While German aircraft were magnificent specimens, powerful, sleek, and meticulously crafted, they ultimately were part of a broader system that was hampered by industrial capacity constraints, strategic miscalculations, and ideological rigidities. The American approach, on the other hand, recognized that victory in modern warfare was rarely achieved by a handful of superb machines alone. It required the continuous and abundant production of reliable aircraft, supported by a robust logistical framework and sustained operational capability over time. This comprehensive industrial and strategic approach allowed the Allies to amass a formidable force, one that could not only match but often surpass the Germans in terms of quantity, operational readiness, and endurance, thereby granting them a decisive edge at the critical moments of battle. In the course of their operational history, certain aircraft that once demonstrated impeccable performance gradually became less and less reliable and effective. As time went on, the overall quality of manufacturing standards began to deteriorate, leading to a decrease in the durability and dependability of critical components. Maintaining these aircraft turned into a more challenging task, as parts grew increasingly difficult to source or replace. The scarcity of essential components, combined with logistical hurdles, meant that keeping the aircraft in fighting condition became a complex and often frustrating endeavor. Additionally, the fuel supply, which was vital for sustained operation, started to become scarce or irregular, further hampering their readiness and operational lifespan. Meanwhile, contrasting sharply with this decline, the P-47 Thunderbolt consistently remained in service, frequently flying missions regardless of the circumstances. This rugged aircraft could absorb significant damage without losing its ability to return safely to base, giving it a resilience that was rare for fighters of that era. It was capable of operating effectively from rough, unprepared airfields, which were often the only options available in the chaos of wartime terrains. One of its notable strengths was the simplicity and robustness of its design. Mechanics with average skill levels could perform necessary maintenance, without specialized tools or extensive training. This meant that even in less than ideal conditions, the aircraft could be kept operational. Furthermore, the P-47 could be flown safely by pilots with minimal training, expanding the pool of capable operators and increasing operational flexibility because there were always more pilots than highly trained specialists. At the very same time, perceptive military observers and engineers, such as the individual known as Lerchers, recognized the significance of these qualities almost immediately. In November of 1943, he authored a detailed report that accurately forecasted how these trends would unfold over the following year and a half. His analysis demonstrated a clear understanding that reliability and operational resilience often trounced raw performance or advanced technological features in a wartime context. Unfortunately, his insights were dismissed or ignored at the time, filed away and forgotten, because acknowledging the truth posed an inconvenience to prevailing beliefs and conventional wisdom. The unpleasant facts that aligned with his predictions did not fit neatly into the narrative that performance and cutting-edge technology were the ultimate measures of a fighter's worth. If one finds these considerations concerning engineering philosophy and strategic design choices intriguing, it is worth exploring further. The historical record is replete with instances where the evident truth was disregarded simply because it conflicted with more comforting notions or traditional practices. A notable example is Hans-Werner Lerche, who served as a pilot flying the P-47 Thunderbolt. He quickly realized that, although the aircraft did not necessarily boast the highest speeds or the most advanced stealth features, it embodied a superior approach to fighter design, one that prioritized operational effectiveness over sheer performance metrics. He understood that this aircraft excelled not because it set speed records or showcased exotic aerodynamics, but because it was built for the brutal realities of war, where durability and reliability could mean the difference between victory and defeat. Unfortunately, the value of Lerche's insights was largely overlooked during his lifetime. Instead of being recognized for his understanding of what truly mattered in wartime aircraft design, he found his ideas dismissed or marginalized. As history unfolded, the predictions he made proved to be correct. The more technologically advanced or ostensibly better fighters, like the Luftwaffe's fleet of advanced aircraft, gradually lost effectiveness under the pressure of sustained conflict, primarily because they lacked the resilience and operational availability that the P-47 offered. Germany's aircraft, despite often being technically superior on paper, was ground down by an enemy capable of maintaining greater numbers of aircraft in flying condition, an advantage rooted in design philosophy rather than raw power. This crux of the matter, the importance of reliability over peak performance, contains a timeless lesson. In protracted military conflicts, an aircraft's ability to reliably stay operational and continue fighting far surpasses moments of fleeting excellence or record-breaking feats. Operational availability, the proportion of time and conditions in which a combat aircraft remains ready to fly and fight, becomes the most critical metric of a platform's success. And at the core of this principle lies the fundamental importance of thoughtful, pragmatic design, prioritizing simplicity, ease of maintenance, and durability, over pursuing advanced but fragile technological features. The story of the P-47 Thunderbolt underlines a crucial insight. While it was not necessarily the fastest or most sophisticated fighter of World War II, it arguably exemplified the best design philosophy for wartime needs. The aircraft was created with the explicit purpose of enduring the harsh realities of combat, not for showy displays in air shows, record-breaking attempts, or highly specialized record flights. Its design was grounded in practicality and the brutal demands of real war, emphasizing robustness, ease of repair, and operational uptime. Because of this, it could sustain prolonged fighting and keep more aircraft in the air over the long term than its more technologically complex counterparts. Ultimately, the side that can maintain its fighting strength the longest, through resilience, reliability, and simplicity, has the greatest chance of emerging victorious in a relentless and extended war. In this battle of principles, the emphasis on solid, dependable engineering and a pragmatic approach to design often outweighs the allure of the latest technological breakthroughs or fleeting performance peaks. The enduring lesson from the history of the P-47 Thunderbolt remains clear. In warfare, longevity and sustained operational capacity are often more potent than the most advanced or fastest aircraft because they enable the endless endurance needed to secure victory against all odds.